Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss Sommerfeld's modification of Bohr's theory. Let's begin. There are so many limitations of Bohr's model of an atom. One of such limitation was Bohr's model of hydrogen atom can't explain the fine structure of hydrogen atom. Fine structure means we notice so many spectral series as Lyman, Balmer, Paschen, Beckett, Pfund. These are the spectral series in case of an hydrogen atom. If we consider one such line of such spectral series through a high resolution spectrograph, this spectral line is not a single line. That one is a number of lines which are very close to that single line, that could not be explained by Bohr. Which one is the limitation of Bohr's atomic model, and that splitting of such spectral line we called the fine structure of hydrogen atom. Bohr's model could not explain the fine structure of hydrogen spectral lines. Therefore, another scientist, Sommerfeld, modify Bohr's theory by taking the assumption that electron move in elliptical orbits in general with nucleus at one its foci, and the circular orbit of Bohr are the special case. As Bohr proposed the postulate, electrons revolve around the nucleus in a permitted circular orbits, and that permitted circular orbit is defined as the electron angular moment of such electron is integral multiple of h by 2 pi. Sommerfeld modify that is not circular orbit, this one is an elliptical orbit, whereas the nucleus is one of its foci of such ellipse, and that circle is one of the special case of such elliptical orbit. Okay, let me explain it. This is an elliptical orbit. It has major axis and minor axis. This portion A, which is called semi major axis, similarly that is the minor axis, and this portion B as the semi minor axis. Electron having the mass small m, it has the velocity v, that elliptical orbit has two foci. This one is a focus, that one is another focus, and we consider one such foci where nucleus is present, and the charge of nucleus Zd, and electron revolving around that nucleus in such elliptical orbit with the velocity v. and it creates at an angle theta to that of nucleus. When electron revolve around that of nucleus, so that distance as well as that angle also changed. Due to this, that electron has two types of momenta. One is the momentum due to that change in distance. That type of momentum we call radial momentum. Again, another momentum developed due to that change in angle, which is called angular momentum. Since radial momentum as well as angular momentum are in case of such elliptical orbit, and it's a periodic manner. So these quantities are quantized in nature. Therefore, Sommerfeld used the quantization rule. According to Sommerfeld's quantization rule, p theta, which is angular momentum of electron, angular momentum is quantized. So integration, that is the closed integration p theta d theta is equal to n theta s. It is quantized, whereas n theta stands for azimuthal quantum number. Next, another momentum developed due to the change in that distance, which is called the radial momentum, denoted by PR. Again, that radial momentum is quantized. The closed curve integration PR dr is equal to nRh, whereas nr stands for radial quantum number. So these two momenta are now quantized by Sommerfeld's quantization rule. According to classical mechanics, the angular momentum of an isolated system remains conserved. That angular momentum, when that electron revolve around that nucleus in such an elliptical orbit, if that system is isolated, means no another influence of systems to this system, then that angular momentum is conserved in nature. That's why p theta is constant in that of integration p theta to that of outside, closed integration d theta n theta is, that is the total integration over that theta. Theta changes from 0 to 2 pi, that integral result 2 pi. Next, p theta is equal to n theta s divided by 2 pi, equation number 3. Next, to dealing with another equation number 2, first we have to remember a point. The polar equation of ellipse 1 by r is equal to 1 minus epsilon cos theta divided by a whole into 1 minus epsilon square. This is the equation of an ellipse in polar form. In 3D geometry, we know it. And again, epsilon, which is the eccentricity in an ellipse, the relation of eccentricity to its semi-major and semi-minor axis, 1 minus epsilon square under root is equal to b by a. B semi-minor axis, A as semi-major axis. Now differentiating that equation with respect to theta. 1 by r with respect to theta minus 1 by r square dr by d theta, that term as constant, then differentiating it with respect to theta, derivative of cos theta as minus sin theta, minus minus plus, so epsilon sin theta divided by a whole into 1 minus epsilon square, that minus is multiplied, again we multiply a r on both sides. So 1 by r dr by d theta is equal to minus r epsilon sin theta divided by a whole into 1 minus epsilon square. In that of equation number 4, if we evaluate the value for r and that value is putted here instead of on this here, substituting the value of r from that equation number 4 in RHS, that value of r is putted, and simplifying it we obtain 1 by r dr by d theta is equal to minus epsilon sin theta divided by 1 minus epsilon cos theta. Why we evaluate such equations? As that equation is necessary to solve the second quantized equation, integration over P r dr is equal to nRh. Then from equation number 2, nRh is equal to integration over P r dr. In case of first one, as we say that angular momentum is conserved, and simply we taken angular momentum as constant to that of outside integration, but at that of situation radial momentum is not conserved. Therefore, in place of radial momentum Pr, we write mass into velocity mv. In place of v, that is the rate of change of distance dr by dt. Again, in place of dr by dt, we substitute it as dr by d theta square into d theta by dt into d theta. There will be no such change. We use the chain rule here and arranging as m d theta by dt into dr by d theta whole square d theta. As we know, p theta is equal to mvr. This is the angular momentum, that is the linear momentum into radius mv into r. In place of v, that is r into omega, therefore m omega r square. In place of omega, we substitute d theta by dt. Again, m d theta by dt is equal to that r square to this side, p theta divided by r square. As we previously derived, the result for p theta as n theta is by 2 pi. Instead of p theta, we substitute n theta is divided by 2 pi. That relation is used here. M d theta by dt, m d theta by dt, we replace it as n theta is divided by 2 pi r square. N theta is divided by 2 pi r square. As usual terms, dr by d theta whole square d theta. Look equation number 5. 1 by r dr by d theta is equal to that one. So that value is putted here. N theta is 2 pi 1 by r dr by d theta whole square. Value is putted. The constant terms, as it is integrated with respect to theta, so the terms n theta is divided by 2 pi is the constant. This is outside of that of integration. From both sides, h and h cancelled out, and we obtain nr is equal to n theta by 2 pi integration epsilon square sin square theta divided by 1 minus epsilon cos theta square d theta. Again, we solve it. At that closed curve, whereas theta varies from 0 to 2 pi. So the limit of theta is put at theta varies from 0 to 2 pi. nr is equal to n theta by 2 pi, that is 0 to 2 pi as usual integral, and that integral is in the form of a standard integral. So that standard integral can be evaluated by using that standard integral formula. So it is 2 pi whole into 1 divided by 1 minus epsilon square half minus 1. 2 pi cancel out. So nr is equal to n theta whole into this n theta multiplied within that of bracket terms. So n theta divided by this minus n theta. So that n theta is added to this side. So nr plus n theta is equal to n theta divided by that much. Under cross multiplication, 1 minus epsilon square half is equal to n theta divided by nr plus n theta. This is the relation of eccentricity, as b by a is equal to 1 minus epsilon square under root. Instead of that, we use b by a is equal to n theta divided by nr plus n theta. This is the sum of radial quantum number plus azimuthal quantum number. That is the total quantum number, which is called the principal quantum number. So there is a relation as b by a is equal to n theta divided by n. This is the required expression. By using that expression, we can draw various orbital shapes when electron revolving around that nucleus. By using that equation, we can draw the elliptical orbits. Look here, in that of expression, when we use n theta is equal to 0, means the condition is that n theta not equal to 0. N theta, that is the azimuthal quantum number. Why n theta not equal to 0? If we put n theta as 0, so b will be 0. B will be 0 means, look that figure, b 0 means that the electron move in that of straight line, that passing through that of nucleus. Actually that is not possible. Therefore that is not possible. So the value of n theta never 0. When we starting the value of azimuthal quantum number, we start it from 1. Then if n is equal to 1, the principal quantum number is equal to 1. Therefore the azimuthal quantum number 1 in number, that start from 1. Using that relation, n theta as 1, n as 1. So b is equal to a, semi major axis is equal to semi minor axis. In that of figure, it looks like a circle. For n is equal to 1, that is the shape of that orbit. Next, let we choose the principal quantum number as 2. So it has 2 in number, means azimuthal quantum number is 1, then 2. The condition is that when n is equal to, n theta is equal to, n is equal to, n theta is equal to 1. When n is equal to 2, n theta is equal to 2, at that of situation, b is equal to a. So it is just like circle. Here is b is equal to a. Next, another situation, n is equal to 2, n theta is equal to 1. So 2b is equal to a. So it is just like an ellipse. Here 2b is equal to a, that is n2. Here is n2, n theta 1, and this one as n2, n theta 2. Overall, that shape we notice for principal quantum number n is equal to 2. When principal quantum number n is equal to 3, the azimuthal quantum numbers 1, 2, 3, either 1, 2 or 3. When n is equal to 3, n theta is equal to 3, it is just like circle. B is equal to a. When n is equal to 3, n theta is equal to 2, that is 3b is equal to 2a. This is the ellipse and the relation in between semi major and semi minor axis. When n is equal to 3, n theta is equal to 1, that is the relation in between these two, and we construct such shape of that orbits. By using that relation, the shape of such orbits are seen. Now, the expression for energy when electron revolving in that of elliptical orbit as proposed by Sommerfeld, so that the electron acquired some energy, the total energy due to its kinetic energy plus potential energy. The kinetic energy is given by half m square of the velocity. It has two types of velocity, one is radial velocity and another one is transverse velocity. The radial velocity dr by dt and the expression for transverse velocity r d theta by dt, square of such velocity term, and the potential energy. The potential energy, that is the electrostatic force of attraction in between nucleus and the electron, which one is given by minus z e square divided by 4 pi epsilon naught r. Simplifying it, m dr by dt square half m r d theta by dt square, m dr by dt that is pr m dr by dt, and p theta is equal to m r square d theta by dt as we previously derived, and the expression that one. And finally, there are a number of mathematical lines, but as far as your exam point of view is concerned, that derivation is not required. Only the final expression for energy minus m z square e to the power 4th divided by 8 epsilon naught square h square 1 divided by n square. This is the expression for energy as derived by Sommerfeld by using his assumption as electron revolving around that nucleus in an elliptical orbit. Look at the expression of energy. This is the expression for energy which depends upon that principal quantum number n, depends on principal quantum number n and independent of azimuthal quantum number n theta. No term relating to that of azimuthal quantum number, and that expression is similar exactly as derived by Bohr. Again it is same result as given by Bohr. It is a confusion, as Bohr assumed his theory electron revolving around that of nucleus in a circular orbit, and then he derived the expression for energy, and it fails to explain the fine structure of hydrogen atom. And to explain that fine structure of hydrogen atom, Sommerfeld modified Bohr's theory as electron revolving around the nucleus in an elliptical orbit. But finally, the expression for energy is same to that of expression derived by Bohr. So, Sommerfeld's elliptical orbit theory can't explain the fine structure of hydrogen atom. Sommerfeld's elliptical orbit theory can't explain the fine structure of hydrogen atom. But later on, Sommerfeld modified that energy expression by taking relativity correction, and again he showcased the expression for energy and which can explain the fine structure of hydrogen atom. So here with the help of this video lecture, we understand the concept of Sommerfeld's modification of Bohr's theory. What be the assumption proposed by Sommerfeld? Elliptical orbit, electron revolve around that nucleus in such elliptical orbit. Sommerfeld's quantization rule, angular momentum and radial momentum are quantized, but angular momentum is conserved from the polar equation of ellipse. Next, for quantized of radial momentum, this is the relation between the quantum numbers to its semi-major and minor axis. By using that relation, we can easily construct what will be the shape of such orbits. then expression for that of energy, which is equal to the expression proposed by Bohr regarding energy, and it is confirmed that Sommerfeld's elliptical orbit theory can't explain the fine structure of hydrogen atom. But later on Sommerfeld's correct it by taking the relativistic approach and correction to that of energy term, and finally it explains the fine structure of hydrogen atom. So, with this useful and informative notes, let me wind up the session. Thank you.